Hi everybody. Today we're going to look at a very basic but important part of our automations, which is turning things on and off. There are two devices that I like to use to power stuff on and off: smart plugs and 5-volt relay boards. Smart plugs are great for things that run on AC power and have a plug, so things like grow lights, humidifiers, or some types of pumps. And the little 5-volt relays are very flexible and they can be used to switch AC or DC components, and these components don't need to have a plug. For example, I put a 4-channel relay board just like this one inside a power bar of mine, and it allows me to turn 4 outlets on and off independently of one another. I'm also using a relay board to control some 12-volt solenoids which run on DC. For Wi-Fi outlets, my unit of choice is the TP-Link HS105. It's compact, well made, and mine have all been really reliable, and they're also very easy to set up for Home Assistant. A lot of people also like to use Sonoff products. I haven't used any, so I can't comment on them, but they do seem like a very popular option as well. Setup of these TP-Link devices is super easy. I'll be doing this with an iPhone and Windows 10. We're going to need an app called Casa Smart to configure our TP-Link switch before we get it into Home Assistant. First, download the Casa app and create an account. Then go to Devices and add a device. We want a smart plug, and this HS105 is a smart plug Lite/Mini. Plug your outlet in, and it should start blinking orange and blue. Now go to your phone's Wi-Fi settings and find the TP-Link SSID and connect to it. Now we're going to tell our plug which network we want it to connect to. Return to the Casa app and go to the next step. I'll pick my home Wi-Fi network from this list and give it the password and then hit join. I'll give it a name, and don't worry too much about this name because we can change it within Home Assistant. I'll just call mine TP-Link 1 for now. Alright, now the plug should be on our Wi-Fi network and we just need to bring it into Home Assistant. Go to Configuration, then Integrations, and add an integration with this big plus sign in the bottom right. Search for TP-Link and you should find one called TP-Link Casa Smart. Submit, and finish. Now all my TP-Link plugs, including the new one I just set up, have been pulled into Home Assistant for me to control. Let's add a switch for it on our dashboard. I'll hit the 3 dots in the top right and then Configure UI. Then I'll add an entity card. And I'm going to find my switch.TP-Link1 and add it. Whenever you bring one of these things into Home Assistant, it's going to automatically be assigned the prefix switch dot whatever you called it. Okay, so here I go. I have control over my switch now through Home Assistant, so we can use it in our automations. Let's say that you dedicate this switch to the grow light in your tent and you want to give it a more descriptive name. Go to Configuration, and then Entities, and find your switch here. Click on it, and then change the entity ID to something like switch.4x4light, or whatever you want to call it. If you need a space, use an underscore, and try to keep it simple and avoid any weird characters. You can also give it a friendly name in the name override section. I'll just call mine 4x4light. Now if we go back to our dashboard, the entity that we added no longer exists, so we're going to have to replace it with our renamed entity. After we set up this integration for TP-Link in Home Assistant the first time, as you continue to add these TP-Link switches onto your Wi-Fi, they should get pulled into Home Assistant automatically from this point on, as soon as you set them up in the Casa app. Now let's talk about relays. The main purpose of a relay in our situation is to be able to use a very small amount of power to control a larger amount of power. You might be able to use the pins attached to a board like an ESP32 to switch something like an LED on and off, since we're talking about a handful of milliamps of current and a few volts, but if you want to turn something else more substantial on and off, like a solenoid or something, you're going to need something that can handle more power. This is where relays shine. The brand I'm using here is Elegoo, and I'll link it below. though there are many options that all work the same way. You can find relay boards like this one on Amazon quite easily in 4 or 8 relay configurations. The relays on this board are rated for up to 10 amps of current at 250 volts AC, but do note that the DC power rating is going to be less, and these guys are only rated for 10 amps at 30 volts DC. If you're new to electronics, relays can be sort of confusing, but they're not too difficult. There are plenty of good videos out there that can show you exactly how they work, so I'll just give you the cliff notes. Essentially, the relays that we're working with have 3 screw terminals on each of them. These terminals can be referred to as normally open, common, and normally closed. Each of these relays also has a pair of input pins, and these pins are what we're going to be controlling with our ESP32 boards in order to power the relay on and off. The 2 input pins are connected to either side of a wire coil inside the relay, and when we power this coil up, it magnetically attracts a little arm inside the relay, which is actually the common terminal, and this changes how the common, normally closed, and normally open pins are connected to one another. When the relay is in the normal state, which means the coil is not being powered, the normally closed pin and the common pin are connected to one another inside the relay, and the normally open pin and the common pin have no connection. When we energize the relay and it's no longer in the normal state, the common pin becomes connected to the normally open pin, and it loses its connection to the normally closed pin. You can tell which terminal is which by looking at the label on the circuit board. The center terminal is my common, and it shows it being connected to the terminal on the right, which is meant to show its normal state. That would mean that the terminal on the right is my normally closed contact, and the one on the left is my normally open contact, and I can verify this with a multimeter. As you can see, my multimeter detects that there's continuity or a complete circuit between the normally closed and common pin, but nothing between normally open and common, and this reverses when I power the input of the relay, and it's no longer in the normal state. Now the normally open pin is connected to common, and normally closed is no longer connected to common. So relays don't produce any electricity on these 3 terminals themselves. All they do is move that common armature to make contact with one side or the other. This allows us to pass power through it, and it gives us the ability to turn things on and off by making and breaking that connection. Let me show you. For this example, I'm going to use this little 4-channel relay board to control 4 sets of these LED strips called Buddies, made by a company called LED Technic. Quick little aside here, these Buddies are some neat little lights. They run on 24 volts and come in 6-foot lengths, and you can get them in PC red or 4000K white. They each have a couple mounting holes and a little adhesive pad on the back of them, so you can stick them to the roof of your cloner or wrap them around a flowering plant for side lighting or whatever else you can think of. The guy that makes these is actually one of the mods over at our forum at ledgardener.com/forum, and he's our resident LED guru. The guy is an absolute whiz when it comes to this stuff. I'm not sponsored or getting paid or anything for this, but LED Technic did give these lights to me for free to test, and I wanted to mention them because I think it's a really neat idea. Alright, back on topic. The components I'll be using, other than the relay board itself, are an ESP32 powered over a micro USB cable by a 5-volt 1-amp power supply. I'm just using a spare phone charger that I have kicking around for this. I've also got a Meanwell 5-volt 10-amp power supply, which I'll be using to power the relay coils, and so much of this stuff runs on 5 volts, so it's a good idea to get a nice, beefy little 5-volt supply like this. I've got those Buddies, as mentioned, and a 24-volt power supply for them, with a little barrel plug adapter that breaks the plug out to 2 screw terminals. And I've also got a breadboard that I had to cut in half, right down the middle, of course, because these damn ESP32s are too wide to fit on the breadboards that I have. And last but not least, I have a handful of these colorful little Dupont cables for connections. Okay, here we go. We're going to need a micro USB cable to flash this board the first time, and it is critical that you use a cable that is not just meant for charging. You can get different types of micro USB cables, and some of them only have pins to charge. You need one that can charge and pass data. Alright, so plug your ESP32 in on the one side and stick the other end into your Raspberry Pi. Again, this goes into your Pi that's running Home Assistant and not the PC that you're using to set this up. Now go to the ESP Home add-on that we installed earlier and click the pink plus sign and start by giving your node a name, all lowercase and no spaces. I'll call this 4-channel relay or 4ch_relay, and then specify your device type here. I'll just pick the generic ESP32 option for mine, which will probably work for most cases. Now enter your home Wi-Fi credentials and hit continue and submit. Case matters here, so get all your uppercase and lowercase stuff right for your SSID and your password. Now we're going to select our upload port. Your ESP32 needs to be plugged into the USB port of your Pi for this step. You should be able to see an option called OTA. This stands for over the air. We don't want this just yet, but after we're done this initial flashing with the USB cable, we can use OTA to just use Wi-Fi to upload any changes to these boards, which is incredibly handy. But you should also see another option, and if you can't, go into Supervisor and then go to ESP Home and restart the add-on. So I had to do this myself, and doing a restart now allows me to see this CP2102 USB to UART bridge controller, which is that micro USB connection to the board. If you still can't see this option after doing that restart of the add-on, then maybe try switching your USB cable because there's a really good chance that you've got the wrong type. Okay, now we've got to program our ESP32 for the relays. I'm going to go to esphome.io and search for a GPIO switch. GPIO stands for General Purpose Input Output, which is what the pins we're using on our ESP are. I'm going to copy this little chunk of YAML and then return to Home Assistant. I'll hit edit on this node that we created and paste that YAML in. We've got 4 relays, so I'm going to paste in 4 sections underneath the part that says switch. The pins I want to use on this board are 25, 26, 27, and 33, which are all suitable for this purpose and are right next to one another too. If you have a different board or want to use different pins, your best bet is to Google which pins can be used for which functions on your particular board. On an ESP32 like mine, these ones will work just fine for relays. These relay boards work kind of opposite to what you'd think, and we actually have to invert each one of these pins in order to make them work right. If you don't invert them, the relays will be on when Home Assistant thinks they're off, and vice versa. The last thing to do here is to go in and give each one of these GPIO switch entries a unique name. I'm going to call mine Relay 1 through Relay 4. Okay, that's it. Obviously, this ESP could be used for tons of other stuff in addition to running these relays, but this is all we're going to do here for now. But it's just a matter of adding more YAML. So save your work and hit upload. It'll take a little while for it to compile and upload. Here's a bit of a gotcha. Some ESP32s are finicky and they require you to press the boot button at a certain time when you're loading to them, or it'll fail. Other models of ESP32s don't care and upload just fine, and I have some of each type. If your upload fails and you get an error about waiting for packet headers or something to that effect, you probably have one of these finicky boards. No worries, just close the window and then this time, hold the boot button down and then click upload again and keep holding the boot button until you see it actually start transferring, and then you can let go. Alright, so just hit stop to close out of this monitor, and now you should be able to see your node online. Unplug it from your Pi now and plug it into your power supply. From this point on, this ESP is only going to communicate with Home Assistant over Wi-Fi. We've just got to finish bringing it into Home Assistant at this point. Go to Configurations, Integrations, and your node will likely show up as a discovered ESP Home integration. If for some reason it doesn't, you can find the IP address of your node by going into your router interface and then adding the ESP Home integration manually with that IP. Hit Configure, Submit, and click Finish. Now let's make it available on our dashboard. I'll add an entities card and then find our 4 relays. Again, they're all going to have a switch dot something prefix. If you want to change the names of each of these relays, you can do it in the same manner that I showed earlier for the TP-Link entity. We're done in Home Assistant now, let's wire up the relays. There are two ways to configure the relay board. You can run it in an isolated mode where the ESP remains isolated from the 5-volt side of the relays, which I would say is the better way to go, or you can run it so the ESP is not isolated from the relay coils, which works too, but doesn't offer quite as much protection for your ESP. To run isolated, you'll need two separate power supplies, one for the ESP and one for the relays. To run without isolation, you just use a single power supply for both. We're going to set this up so it's isolated. To do this, I'll remove the jumper on the relay board between the VCC pin and the JD VCC pin. Now I'm going to connect the positive of my Meanwell 5-volt power supply to the JD VCC pin, and I'll connect the DC negative of my power supply to this little pin on the relay board marked ground. So this is going to power the relay coils. Now I'll connect the ESP32 3.3 volt pin to the VCC pin on the board, and then we're going to hook up the pins that we configured in ESP Home earlier. So we'll go pin 25 to input 1, 26 to in 2, 27 to in 3, and 33 to in 4. Okay, time to get everything else lined up. Next thing I'll do is wire the positive of my 24-volt LED power supply into the common terminal of Relay 1. And since all these lights are going to be sharing this power supply, I'll parallel all of my relay common pins together with little jumpers. This way, I've got plus 24 volts running to the common terminal of each one of my relays. If you wanted to run devices that use different voltages hooked up to each relay, you could easily run different power supplies to each one of them, so you could have, say, 12 volts DC on the first one, 24 volts on the next one. It doesn't really matter. You just wouldn't connect them together, obviously, like I've done here with my little jumpers. I've got 4 separate buddy strips for this test, and I'm going to hook the positive wire from each strip up to the normally open pin of its respective relay. I want to use the normally open pin because I want the lights to be off when the relay is in the normal state, which is when the coil is de-energized and it's off. So now I have my power supply hooked up to the 4 common terminals, and each positive wire of my 4 strips is hooked up to the normally open terminal of its relay. Now I'm going to splice all the LED negative wires together, and I'll connect these directly to the negative of the LED power supply. So the negative side doesn't go through the relays at all, it's a direct connection from the LED strips to the LED power supply. Alright, time to plug it all in. Once the ESP comes up, I can use the switches we added to our dashboard. When the switch gets toggled, the relay coil gets energized, and the common pin, which has plus 24 volts on it, gets connected to the normally open pin, which has my LED strip on it, and power flows. Here's a diagram of the whole thing. You can pause if you want to take a look. And here's a close-up of just the ESP and the relay board. Here's another quick example with a peristaltic pump and a 12-volt power supply that I have. I've already wired the negative of the pump to the DC negative of the power supply, and now I'll wire the positive of the pump to the relay's normally open terminal, and the positive of the power supply to the relay common terminal. Same thing as the lights, but a different device and power supply. Again, the only reason I tied all the common terminals together with the 4 lights is because these lights all run off of the same power supply, and it was an easy way to split the power between all of them. And now I have control over the pump from Home Assistant. I'll pump like this might not be a great example because you'd probably want to use something that can control the speed of it instead, but it's a component that I had kicking around, so it'll have to do. So now I have control over 4 different things with this relay board, and for stuff with an AC plug on it, I can just keep adding TP-Link outlets. Now that we have the ability to turn a very wide range of devices on and off, we can start incorporating this into some more complex automations. In the next video, we're going to look at a couple different options for getting temperature and humidity readings from your garden into Home Assistant. Until then, if you guys run into any problems or have any questions, feel free to post them over at ledgardener.com/forum in the Home Assistant Gardening Forum, and we'll see if we can get you sorted. And we'll see you on the next one.